Hi, this video is on a real number system, and the real number system is like Tupperware, nested in each other, where we have small sets of numbers that fit into larger sets of numbers that fit into larger sets of numbers. And that's how our number sets work. You'll notice that we have one container that's kind of separate from the rest. And we're going to learn that there's one category of numbers that's a little different from all the other ones that fit together. So on page 27, they give you this diagram, and they use short form. They use letters to stand for the different sets of numbers. All of the sets of numbers that we look at are called real numbers. So we're going to start in the middle at the smallest set, which has the letter N, and that N stands for natural numbers. Natural numbers are the counting numbers that we first learn as children. We start to count on our fingers, 1, 2, 3. So our natural numbers, these numbers are our counting numbers, and we go up from 1, counting upwards, 1, 2, 3, 4, 5, and so on. After we learn the natural numbers, then we get to the next set, which is a little bit bigger, but includes the natural numbers. And the W stands for whole numbers. The whole numbers are natural numbers, just with one additional number, and that is 0. So 0 gets introduced, it belongs to the set of whole numbers, and then we include those counting or natural numbers. After that, the next set, the I, or integers, includes all of the whole numbers, and it includes all of the natural numbers. But what makes integers different is that now we don't just have 0, 1, 2, 3, 4, 5. We don't have positive numbers, we have their opposites. We now get into the negatives. So integers are positive and negative whole numbers. So we could go -2, -1. Now we can include the whole numbers 0 and natural numbers 1, 2, 3, and so on. So we can go in both directions. Whole numbers positive, whole numbers negative are part of the integer set. And then the outer or largest set is the letter Q. The Q stands for rational numbers. So rational numbers are numbers that can be expressed as fractions. So a rational number can be expressed in a fraction form, where we have A over B, and the rule is we can't have B equaling 0. So we can't have a division by 0. That gives us an error key, or is called undefined. So rational numbers, we could have any of our integers, because we can put those numbers over 1. Any of our whole numbers we can put over 1. Any natural numbers we can put over 1. We can turn those into fractions. Some examples of rational numbers would be like 1/3, so regular fraction, or -2.5. We can express it as a decimal. So our fractions and decimals, those are included in the set of rational numbers. Remember, rational numbers also include all the integers, all the whole numbers, and all the natural numbers as well. The last set you see over on the right, I'm going to write it over here, is Q with a line over top. This set is the one that's a bit different. If you remember that Tupperware, the one that's kind of off on the side. These are our irrational numbers. The thing about rational numbers, when we have decimals and fractions, is they typically will have a pattern, or they'll end, like 2.5. Irrational ones are the ones that where we have, they're non-terminating, so they don't end. Or we can say that they're non-repeating, so there's no pattern. that we can identify. Some examples of irrational numbers are a lot of square roots, so like the square root of 2 or the square root of 7. If you try those on your calculator, you're going to get a big long decimal that doesn't seem to end and doesn't seem to have a pattern. And also, most famously, pi. Pi is a non-terminating decimal as well. So those are irrational numbers. Even though they're irrational, they still belong to the group of real numbers. All of these, the natural, the whole, the integer, the rational, and the irrational, are real numbers. This diagram is not in your workbook, but I like it because it has good examples. So I have this in Moodle for you should you like to access it. It's under the resources in Unit 2 Equations. So we can try a few questions now about rational numbers. Number A, or the example A on page 28, first one is a square root of 5. So if we take the square root of 5 on our calculator, we get 2.236067977. So we don't see any pattern there, and our calculator runs out pretty quickly, but doesn't appear to be ending. It's a non-terminating. So we can be pretty confident that this is not a rational number. Rational numbers can be fractions, decimals, but they have predictability to them. So this one we would say no, this is an irrational number based on the information we have. Compared to B, where we have 0.03 repeater, so here we have a repeating decimal. We know that the next number will be 3 again, and 3 again, and 3 again. So there's that predictability. So yes, this one is a rational number. On page 29, they ask a really good question. They ask you to give an example of a number that is an integer, but is not a whole number. Well, there's so many possible answers to this question. And that's because if we look at what integers are positive or negative whole numbers. But when we look at the set of whole numbers, what does that include? Whole numbers include 0, and then the natural numbers, like the 1, the 2, the 3, the 4, the 5. So an integer that is not a whole number could be any negative number, any at all. So you could give -1 as an answer. You could give -272 as an answer. Any negative number is an integer, but not a whole number. And I should clarify there, when I say any negative number, I mean any negative whole number. We wouldn't have a negative decimal here. We wouldn't have a negative fraction here, because remember, integers are negative and positive whole numbers. I thought we could take a look at a few practice exercises on page 35 if you'd like. So we're looking for the sets of numbers that each of these belong. So the first one looks kind of funny. It's 2/3. So we're looking for the sets that this number 2/3 belongs to. Remember, all of the kinds of sets that we've looked at are real numbers. So we can put an equal sign here, and we're going to use R to represent real numbers. So yes, 2/3 is a real number, but then other sets. Which other sets does it belong to? So I'm going to look downwards. So is it a rational number? Yes, it is. It's rational because it's expressed in a fraction form. And then you have to ask yourself, okay, it's expressed in a fraction form. Is it an integer? Well, it's not an integer, is it? Because integers are positive and negative whole numbers, and 2/3 is a fraction. And it can't be a whole number because it's a fraction, and it can't be a natural number either. So it belongs to the two sets, real numbers and rational numbers. For B, we have -3. So -3 is definitely a real number And then we have to ask ourselves, is it a rational number? Well, can we turn it into a fraction? We can. -3 can be placed over 1, so that means that it is a rational number. And then we go down. Is it an integer? Well, yeah, it's an integer because it's -3, so it's a negative number. It's a negative whole number, so it's an integer. Is it a whole number? No, it's not a whole number because it's negative. Whole numbers start at 0 and go up from there on the positive side. And it's not a natural or counting number either because it's negative. So -3 belongs to the 3 sets: real numbers, rational numbers, and integers. Couple more a little bit later on. One of them I don't really like, and that's I, because it's 776.0. Well, let's just start at the beginning again. It's definitely a real number. Is it a rational number? Can I place this over 1? Well, I can, because I can get rid of that 0.0 and have 776 over 1. So yes, this is a rational number as well. Remember, 776.0 is just 776. So I can place that over 1. That's rational. Is it an integer? Integers are all positive and negative whole numbers. Again, the decimal here doesn't mean anything. If I take it away, it doesn't affect the value of that number. So yes, it is an integer. Is it a whole number? It could be. Let's take the decimal away. Is it a natural number? Can you count from 1, 2, 3, 4, 5 up to 776? Definitely. It belongs to all the sets, except for the irrational, of course. So that one is a bit of a strange one. And the last one here is J. It's the square root of 121. So what is the square root of 121? We solve it, and that's equal to 11. So we go back through our sets. What is 11 when we look at that? Well, that's a real number. It can be placed over 1. It's a rational number. It's an integer because it's a positive number. It's a positive whole number. And right there we said it, it's a whole number. And it's a counting number. It belongs to all the sets as well. These questions take a little bit of getting used to, but they are good for us to be able to memorize the sets and to understand that small sets like natural numbers are included in the larger sets, that rational numbers include all the integers, which includes all the whole numbers, which includes all the natural numbers. And it's also good to know what makes a number rational compared to irrational.